Hello, welcome to these lessons where we are teaching mathematics, grade 8 up to 12, and this particular lesson is meant for grade 11s, okay? Those people that are preparing for their grade 12 exams, then GCE people, please, you are welcome to this channel because we are providing lessons that are beneficial to you. So we are looking at second theorem, and I want to look at theorems that are associated with the cyclic quadrilateral. This is the third lesson that I'm presenting under this topic. So today we want to look at, there are three theorems that I already looked at. Okay, so this is like lesson 3. So I would request that you look at the previous lessons. Okay, so under this lesson, I'm going to look at the theorems that are associated with the cyclic quadrilaterals. What is a cyclic quadrilateral? First of all, a quadrilateral is a four-sided polygon. It is a four-sided polygon. But now that we are talking about a four-sided polygon in a circle, that is why we are calling them cyclic quadrilateral. It means a quadrilateral in a circle. Okay? So we've got two theorems that we're going to look at under cyclic quadrilateral. So the first one is this one that says opposite angles of a cyclic quadrilateral add up to 180. That is, it's as simple as that. There is nothing that I can add. Opposite angles in a cyclic quadrilateral, they add up to what? 180. Just like I've given an example here. Just like I have given an example here. X, this is an angle which is opposite to that one. These two angles will add up to 180. The same applies to this. If this is A and this is 2A, when we add this 2A plus 2A, we need to equate them to what? 180. Okay? The angles, they should both be on the circumference here. They should be, we are not talking about something like, we're saying opposite angles. We have a circle here. So, maybe some of you just look at this. These two sides, these two, they are not on the circumference, no. So this, you can't say this one adds to 180 with this one. No, this is not what we are referring to. These angles, it should be on the circumference, like this. Therefore, in this case, we have this one is opposite to this angle. Therefore, they add up to 180. The same applies to this angle as well as that one. They add up to 180. Okay? I hope you are getting that. I hope you are getting that. I hope you are getting that. Okay? Now, the way these questions do come in the exam, it's combined with other theorems. So you need to pick which one is applicable here, which one is applicable here. So that is why in the questions, in the exams, they are integrated. So we are trying to present them to you one by one, but in the questions, they will be combined. So we need to make sure that we appreciate all the theorems so that we do not get stuck in the exam. Okay, so this is what I'm trying to explain here. You have, then what do we have? We have a circle like this. Okay, this is the cyclic quadrilateral here. It will still be applying. This is opposite to that one. This one is opposite to. So we are saying opposite angles in a cyclic quadrilateral add up to 180. Opposite angles in a cyclic quadrilateral add up to 180. So we need to get to know that theorem. All right. We need to get to know that theorem. So I can move on to another, the second concept or the second theorem or property. So this one we are done. This one we are done. Now, I want you to look at this case. If we say this one here is 140, if we say this angle here is 140, hope you're paying attention. If we say this angle here is 140, what is this angle? This angle is 140. What is this angle? This angle and this one, we say they should add up to 180 because they are opposite angles in a cyclic quadrilateral. Okay. So when we subtract, we are going to get that this one is 40 degrees. Then we have another rule of angles where we are saying angles that lie on a straight line add up to 180. If you've got two angles that lie on the straight line, they add up to what? 180. Are you following? They add up to 180. Angles that lie on the... So this angle here, which is 40, as well as this one, they are angles on a straight line. So they should add up to what? Up to 180. So what are we saying? This angle also, to find this angle, subtract 40 from 180. So it will still be also 140. So what conclusion have we made? This 140 is equal to that one. This is equal to that. And it brings us to what? The external angle. What is the external angle? This one here. Pay attention. The external angle of a cyclic quadrilateral, the external angle of a cyclic quadrilateral, which is 140, the external angles here, okay? The external angle of a cyclic, we can say here, is equal to the opposite interior angle, because I have tried to explain how it comes about. Is equal to the opposite interior angle. Okay? So that is another theorem which I was trying to explain here. Oh, it's actually not this one. It's this. Okay. This one here. Okay. No, this is opposite to this one. Not this one. I'm sorry about that. Okay. So this is another theorem that you need to know. So I have talked about two. The first one that was talking about opposite angles adding up to 180. Then these are equal. One is an exterior, the other one is the opposite interior angle. Opposite interior angle. Okay? Opposite interior angle. So like this one here. Which one? It adds this angle and this one, they add up to what? 180. So the angle that it adds with one, then we want the other one. You get my point? That is the point. The opposite angle. This is opposite to this one, except that we're saying the other one is an exterior angle. Okay? We were saying this one and this 40 and this one, they're opposite angles. Now, both of them are inside the quadrilateral. But here we have one. So we are saying the external angle of a cyclic quadrilateral is equal to the opposite interior angle. So this one. Okay? This is the point that I wanted you to get. If we look at this one, let me write something here. Okay? This is Y. Y is A, B, C. Y is opposite. Which one is its interior angle which is opposite to Y? Between these, amongst these three letters here, or these three angles. This one, this angle, and this one, they add up to 180. So the opposite to B, the opposite external angle is this one. So this angle and this one, they are what? They are equal. They are equal. If we are extending this line here, if we are taking this line, what are we dealing with? This angle. This is equal to which one? This one here. Okay? Take note of that. If we are extending this angle here, this is equal to, take note of that also. I hope we are trying to get the idea. I hope we are trying to get the idea. Hope we are trying to get the idea. I hope we are trying to get the idea. So, if I can just give an example which is very simple. Okay, you have got okay. So if we call this angle 55 degrees, okay? What is this angle here? What is this angle? this is what I'm practically telling you, that this angle is equals to, if I want, I can, let me just do this, okay? So here, what do we have? We have A, and the other side here we've got what? B. So angle B, what is angle B? Angle B, you get the relationship that we talked about, this and that. The interior angle is equal to the opposite external angle. So B is also equals to 55. This one, they add up to 180. So to get A, you subtract this one from 180. You subtract 55 from 180. That is going to give you the value or the degrees for A. So let me give you more examples so that you can see what I'm talking about. Let's look at these examples. Let us look at these examples. We remember the theorems that we talked about. So in these examples, the question is find the angles. Find the angles marked with letters. Find the angles marked with letters. So the first one is this one here. What did we say? Opposite angles in a cyclic quadrilateral add up to 180. So we are saying 2x plus 70, they should give us 180. So we say 2x is equals to 110 when you subtract this 70 from this one. Then x is equals to what? 55. Okay? X is equals to 55. You divide 110 by, so that is our x. Alright? That is our x here. So we have known what our x is. So if you want to know what y is, now we are going to say, since we know that now y, x and y, they add up to what? 180. They are also opposite angles. X and y, they add up to what? Then y is equals to 180 minus 55. What do we get? Okay? What do we get? 180 minus 55. Okay? What do we get? 180 minus 55. Y is giving us, when we subtract here, what are we getting? 125. 125 is what y is going to be. Okay? Exactly that. So basically, this is what we are supposed to do when we are looking at. So we proceed. Let's look at the second example. I'm done with this one. Let's look at the second example. So in the second example, as you can see, what does this mean? This means this is an isosceles triangle, and it's like this. Okay? These two angles are equal. This one and this one are equal. Are we together? That is what that means. That is what that means. Okay? So if you remember what we dealt with, the second theorem that we looked at, we said, first ignore this line. Ignore this line here. Okay? Ignore this line. What did we say? This angle here, oh, what was this? It was 106. Okay? This is supposed to be 106. So this angle here, we said it's equal. This is where we're talking about the concept of the exterior angle and the interior angle. So this angle and this one, they are what? They are equal. This angle, it is also what? This angle here, it is also 106. Okay? So if this is 106, now we need to find the value of what? The value of k here. So we're going to use the 180 minus 106. What do we get? 4. We have 7 minus 0, it's 7. This is what we are getting. Then this one is the sum of these two angles. This is the sum of these two angles. Okay, so you divide, because we are saying these two angles are equal, so we divide this one by 2. Okay? 2 into 7, what do we get? 3. And then we have a 1. In 2, we have 37. So this is 37. Even this one is 37. Okay? So the value of k here, the value of k is equals to, we need to divide. Remember what we said? We said we need first of all to say 180 minus 106. Then this should be divided by 2. Then we are going to get what? What we are going to get here will be what? 74. 74 divided by 2. It's going to give us 37 degrees. And that is what is going to be the value of k. So you see, we are applying those same theorems. We are applying those same theorems. Okay? So let's look at the last one. Let's look at the last one. What is the value of A? What's the value of A? We are saying A plus 63 should give us what? 180. Opposite angles in a cyclic quadrilateral. Then A is equals to 180 minus 63. Let's do the grade 6 division, subtraction here. This gives us what? 7. Okay, what do we have here? What do we have here? We have 1, 7 minus 6, we have 1. So A is equals to what? A is equals to 117 degrees. So that when we add these two, they must give us 180. This one as well as that one. This is our A. We go to B, the last one. We go to B, which is the last one. We are saying these two angles, when we add them, B plus 2B should give us 180. This is going to be 3B, our algebra. Okay, this is going to be 3B. So B is equals to what? 180 divided by 3. And B is going to give us, this is 60. So B is equals to 60 degrees. So meaning, this is 60 degrees, then this one is going to be 2 multiplied by B to be 120. So basically, this is how we can use these theorems to calculate the values of the angles that the questions are asking us. Okay? So, look at, in the previous lessons, I looked at 3 theorems. Here, I looked at 2. So, we are remaining with those now that are associated with tangents. Then afterwards, I'm going to give you now a collection of questions from the past papers, those that combine all the theorems. So, on that part, I'm going to present 2 lessons. Okay? So let me give you an exercise, those questions that you can try. Okay, so the questions are here. Find the angles marked with a letter. So we have 1, 2, 3, 4 here. We have 5. This is something that I gave you. This was the example. We can also look at this one. Okay. It's the reverse of the other one. Think about this one also. You need E and F. Okay, you can bring in the first theorem that we looked at in this one. Okay. Read this question here also. Okay. Do this question here, this question. There's also this one, number 4. Okay. We also have number 5. Okay. Also number 6 is here. I hope you're able to see this is 50 here. Okay. So this one, you need to think of what we did. Also, you combine with other theorems that we have already looked at. So here, the question is that find the angle that is marked. This angle that has got 2 lines here. The angle at the center. Find that angle. That's the question. Okay. You can look at just C here. Just look at C. This one. There's this question. Find the value of X. Okay. This one here. The last one. The one that has 102. Find that angle that is marked there at A. That angle there. Okay. Otherwise, thank you so much for watching. Do these exercises and watch more videos. There's no way you can fail mathematics. Thank you once again.